For our final example, let's look at one that's a bit more complex. 6x plus 2y equals negative 10, and negative 4x plus 7y equals 40. Without using fractions, there's no way to multiply only one of the equations by a value to get opposite coefficients for either of the variables. So the key here is to think in terms of the least common multiple. Remember that the least common multiple is the smallest number that both of the numbers will go into evenly. Since the x's have one positive coefficient and one negative, let's find the least common multiple of 6 and 4 to get us started. 4 does not go into 6, but if we look at the next multiple of 6, which is 12, we find that 4 does go into that 3 times. So 12 is the least common multiple of 6 and 4. Our goal now is to get a plus 12x in the first equation and a minus 12x in the second equation. To do this, we are going to multiply the first equation by 2 to get 12x plus 4y equals negative 20. Notice that I was careful to be fair and multiply all three terms by 2. Next, we are going to multiply the second equation by 3 to get negative 12x plus 21y equals 120. Again, be fair and multiply all three terms by 3. Now we have the opposite coefficients we needed. When we add the equations together, notice the x's will cancel out to 0, leaving only a 25y on the left side. Adding the right sides together gives us negative 20 plus 120, which is 100. Now we have 25y equals 100, an equation with only one variable, so we can divide both sides by 25 to get y equals 4. Now that we know the y-coordinate of our solution, we need to substitute it into one of the equations to find the value of x. Again, we can substitute it into either of the two original equations, so I'll use the first one to get 6x plus 2 times 4 equals negative 10. This gives us 6x plus 8 equals negative 10, so we can subtract 8 from both sides to get 6x equals negative 18, then divide both sides by 6 to get x equals negative 3. Now we have our final answer. The solution is the point negative 3, 4.